Welcome to YOY TV. Have you ever paused, looked up, and truly wondered about the vast blue canvas above us? Why is the sky blue? It's one of the first great questions we ask as children, a piece of everyday magic we so often take for granted. The answer seems simple, almost intuitive. But the real science behind it is a fascinating story that connects the light from our sun, the very air we breathe, and the way our eyes perceive the world. Many of us grew up with a common romantic idea that the sky is simply a reflection of our planet's vast blue oceans. It's a beautiful thought, but it's a myth. After all, the sky is just as blue in the middle of a continent, thousands of miles from any sea. The truth isn't found by looking down at the water, but by looking through the invisible ocean of air that surrounds us all. The real answer is a tale of physics, a dance of light and matter happening constantly, trillions of times a second, all across the globe. To understand it, we need to break down the two main characters in this story: the light that travels from the sun and the atmosphere it travels through. First, let's talk about sunlight. The light that streams from the sun, traveling 93 million miles to reach us, appears white or yellowish. But as Sir Isaac Newton first demonstrated back in the 17th century with his famous prism experiments, that white light is not as simple as it seems. It's actually a composite, a mixture of all the colors of the rainbow blended together. Each of these colors travels as a wave of electromagnetic energy, and each color has its own unique wavelength. Think of it like waves in an ocean. Red light has a long, lazy wavelength, while blue and violet light have much shorter, choppier wavelengths. This difference in size is absolutely critical. It's the key that unlocks the entire mystery. Now, for our second ingredient, Earth's atmosphere. It's not empty space. It's a dense blanket of gas molecules held to our planet by gravity. This air is composed primarily of tiny nitrogen molecules, about 78%, and oxygen molecules, about 21%. There are other gases in there too, but nitrogen and oxygen are the main players. The crucial thing to understand is the scale. These individual gas molecules are incredibly small, far, far smaller than the wavelengths of visible light that are trying to pass by them. And it's the collision between the sun's light waves and these tiny atmospheric molecules that creates the magic. This interaction is a specific type of light scattering, and it has a name: Rayleigh scattering. Named after the British physicist Lord Rayleigh, who first described it in the 1870s, this phenomenon explains what happens when light encounters particles much smaller than its wavelength. When sunlight enters the atmosphere, it's like a stream of different-sized waves trying to navigate a sea of tiny obstacles, the nitrogen and oxygen molecules. The long wavelength red, orange, and yellow light waves are so large compared to the gas molecules that they mostly pass right through, continuing on their straight path. But the short wavelength blue and violet light is a different story. Because its wavelength is closer in size to the gas molecules, it's much more likely to be absorbed and then re-radiated by these molecules in all different directions. It gets scattered. Imagine our sky as a cosmic pinball machine. The red light is like a giant beach ball that barrels straight through the pins. But the blue light is like a tiny pinball that hits a molecule and ricochets, bouncing from one molecule to the next, scattering all across the sky. This scattered blue light is what comes down to our eyes from all parts of the atmosphere, making the entire sky appear blue. Now, a clever question might pop into your head. If shorter wavelengths scatter more easily, and violet light has an even shorter wavelength than blue light, why isn't the sky violet? It's a brilliant question, and the answer has two parts. First, while the sun is a full-spectrum star, it doesn't emit all colors with equal intensity. Its output of violet light is actually weaker than its output of blue and green light. So right from the start, there's simply less violet light available to be scattered. The second, and more important reason, lies within our own biology. Our eyes have evolved to be most sensitive to three color ranges: red, green, and blue. We are particularly sensitive to blue light, but much less sensitive to violet. So when the scattered light from the sky, a mix of mostly scattered blue, some scattered violet, and a little bit of green, reaches our eyes, our brain processes this combination and perceives it as the familiar, beautiful sky blue. The sky violet, in a way, but our eyes and brain vote for blue. This same science of scattering also explains why the sky changes color so dramatically. At sunrise and sunset, the sun is very low on the horizon. For its light to reach your eyes, it has to travel through a much thicker slice of the atmosphere. This long journey gives the air molecules much more opportunity to scatter the light. By the time the sunlight reaches you, almost all of the short wavelength blue and violet light has been scattered away from your direct line of sight. What's left to continue its journey straight to you? The longer wavelengths, the yellows, the oranges, and the reds. This is why sunsets and sunrises are a fiery spectacle of warm colors. But what about on a hazy day, when the sky looks washed out and pale? Or why are clouds white? This involves a different kind of scattering called Millet scattering. It happens when sunlight hits particles that are larger, like the water droplets in a cloud, or dust and pollutant particles in the air. These larger particles scatter all colors of light more or less equally. And when you mix all the colors of the rainbow back together, what do you get? White light. That's why clouds are white, and why a polluted or humid sky loses its deep blue color. You can even see Rayleigh scattering at work when you look at distant mountains. They often appear hazy and blue. That's not the color of the mountain, it's the color of the air between you and the mountain. The light from the sky is being scattered into your line of sight, tinting the dark mountain with a layer of blue. And this science isn't limited to Earth. On Mars, the story is flipped on its head. The Martian atmosphere is very thin, but it's filled with fine reddish dust. This dust is large enough to absorb blue light and scatter the red light, giving the Martian daytime sky its eerie butterscotch pink color. But the truly alien part is the sunset. As the sun dips below the Martian horizon, the sky around it glows with a haunting blue. It's the exact opposite of an Earth sunset. On other planets, the view is even more different. Beneath the thick sulfuric acid clouds of Venus, the sky would be a dim, oppressive yellowish white. And on the gas giants Uranus and Neptune, their atmospheres are rich in methane gas, which is fantastic at absorbing red light and reflecting blue and green light, giving them their spectacular azure and cayenne hues. Each sky in our solar system tells a unique story about its atmosphere. So, the next time you step outside and look up, take a moment to appreciate what you're really seeing. You're not just looking at empty space. You're witnessing a beautiful, chaotic, and constant display of physics. You're seeing the sun's full spectrum of light interacting with the very air that keeps us alive. A process that scatters blue light across our world while painting our mornings and evenings with fire. It's a reminder that even the most common, everyday things can hold the most extraordinary science. The sky is blue because of a perfect combination of sunlight, atmospheric composition, and the biology of our own eyes. It's a daily spectacle, free for all of us to enjoy. What other everyday phenomena make you curious? Is there another why you'd like us to explore? Let us know in the comments below. Science is all about asking questions, so never stop being curious. And if you enjoyed this journey into the science of the sky, don't forget to like, subscribe, and hit that notification bell so you never stop learning with us here on YOY TV.